should not be kind of passing. Okay, so or last name, oh, funny, because I'm there. So we're going to keep looking at the same code that I already put on web courses with more of a discussion about it. Because what's going on in this source code is actually, there's quite a bit to it. So we're going to continue with our linked lists. All right, so in our code, all right, we create the actual structure. You know, we have those two parts, right? We have that one part that's the data, and the other part that's the pointer to the next node in our list, right? So here we go. And then what we've done, if you look up here, we have that asterisk head. So we're creating an instance of our struct called node during creation of the struct right here in line. So you don't have to do it this way. It's perfectly fine to just have this, and then later on create that instance of the struct called head. But it's just a quick and easy way to create that back. So what this head is going to do for us is he's going to represent our head node of our list. Okay? And then you initialize all your other nodes that you want to do. So here's just a couple of examples. So I did, struct node, and because there's an asterisk in front of it, or the splat is what I like to call it, because that's what programmers call them. So I have the splat in front of 1, 2, and 3. So I have 3 pointers. And these pointers are an instance of node, the struct. Okay? How do I know that? Because I'm saying right here, when I'm doing my variable declaration, I have my data type is struct node. Does that make sense? Anyone confused by that? It's just like saying int. Your data type is an int. Well, in this case, our data type is struct node. So here, I'm actually initializing the data in each one of my nodes. And so for the data portion of my 1 pointer, I'm just setting the data to 1. On the 2, I'm setting the data to 2. And on 3, I'm setting the data to 3. I'm going to initialize my next to null, because then I'm going to actually update them to create that linked list. So right now, all we have literally is just 3 individual nodes. They're not related at all because they're not linked to each other yet. Does that make sense? So we need to create that linked list. Did I lose anybody on that? So right now, it's just 3 individual nodes, and they have no relationship to each other. Yes?
Are we just starting out with 3 nodes, or is it specific we have 3 nodes in this case?
I just created 3. We could have created 5, we could have created 10. It's just for example purposes. Really, it's how much real estate I have on these stupid PowerPoint slides, right?
You're just initializing values just
yes.
Whatever.
Yes.
Okay.
So we're just initializing the data for each one of our nodes, and then we're initializing the pointer portion of our node to null. And right now, we just have 3 individual nodes with no relationship to each other. It's not a linked list. Yes?
Sorry to explain this, but the arrows pointing to like data and index, how come it's not like a varied data?
They're actually both acceptable. That's a very good question. When you are accessing the individual elements in the node themselves, the arrow notation and the point notation both work. Does that make sense?
So you can use either one.
Sorry. Jonathan corrected me. Yes, that is true. But to use the point, to use the period, the dot notation, you have to dereference your pointer. Okay? So put these 2 lines right here, do the exact same thing. Is everyone good with that? You just have that's one of the crazy things about programming. There's always more than one way to do it. Yes, sir.
Because of our pointers, we have to create
the memory allocation. On Wednesday, people were asking me about dynamically creating arrays, right? Well, so you're talking about using a V bracket. That definitely doesn't exist in C. That is a different one. That's like Java. And C# lets you use V brackets. C does not. I did a whole bunch of t-testing just to make sure that I was right about that. And there's no V bracket. There's no generic data typing in C. So this concept of a dynamic array is really, you have to create, there's a lot of programming that goes behind creating a dynamic array. So yes, you can do it, but it really is a combination of doing the malloc, which allocates memory, right? So you do the memory allocation, malloc. Then there's the calloc, where that is the contiguous memory allocation. And there's the free, where you free up memory that you are no longer using. And then there's the realloc, the reallocation of memory. So this concept of a dynamic array in C really is a combination of using those different memory allocations. And so there's a lot of freedom to do a dynamic array. Yes, you can do it, but I don't know, kind of like, rather just do a linked list. One of the examples that, what is it from a roots node, where the assignment, no, it's the assignment that you gave, no, that we taught that version of it, where it's an array list, assignment one was an array list. So you can mimic the array list in object-oriented programming languages, but you still end up having to create stuff. Okay, so the concept of an array list is not just an inherent type. You have to create stuff to make that happen. Yes, sir. Let's look at this here. Okay. So let's look at the actual code example, because this code example is a correct implementation. My slides are merely just a voice track to kind of provide an example, okay? But the real code is where it's happening. All right, so here you see I have my main, and I have two integers. One is I, one is num, and I create an instance of my struct node, and I'm calling it n. And then here, I'm explicitly initializing my head to null, because you really, really, really should initialize data. You want to make sure that you don't accidentally do a buffer overrun, because you can. So like, a student came to my office yesterday, and we were talking about this. He said, okay, so I created a character array, and I gave it a size of 0, but it let me store 15 characters in it. Well, yeah, but you just stomped on memory somewhere else. That's a buffer overload. You only allocated 0 space. So sometimes programming languages will definitely let you shoot yourself in the foot. So that's why you have to understand the actual concept behind it and memory usage to make sure that you don't do those buffer overruns. Because what's going to happen is you're going to want to track that. Okay, if you print that out and then you try to create some more variables and stuff, and then that memory gets stomped on, and it's just big defense. Okay, so yes, you can. Programming languages let you make mistakes. Right? So that's why you sit here and get tortured listening to me telling you how to do it the right way. Okay, so the question is about memory allocation. So here, back. Here, I'm asking the user to pick an option, right? And then I come down here, and I am going to do a display on my pen. So you see that I never did a memory allocation on my pen. And it exists, right? Okay? So this is one of those things where you hear me say this a lot, it's good programming practice. Technically, yes, it works, but you could eventually have problems. So that's why up here you see we're doing a malloc. We're explicitly getting the correct memory size. Now, someone had emailed me and asked me about this explicit typecasting in front of that malloc. Because they did the GTS before they emailed me. You guys are awesome. And we don't have to do that. It's going to work just fine without that explicit typecasting. This is just being overly anal retentive, okay? It's just absolutely positively making sure that it is a struct of type node. Does that make sense? You understand explicit typecasting? Yes? Okay. So, this is good programming practice. This is probably the best way to do it because they definitely are allocating memory.
It returns null to the event that you have in the space. So you can use that to let the user realize they can't create anymore or
Yeah, I mean, it prevents it prevents the crash and burn. You know, like I was showing you on Wednesday when it was Wednesday, it was last Friday. And I was showing you if you leave off some stuff with, we were talking about pointers, the example of the pointers, and you don't do the ampersand for the address of, and you don't do reference at, and it just goes, I don't know what to do, someone's gonna die. Okay, so it's just good in programming practice is what it is. It's a better thing. Anyone fun? All right, so just a quick voice track here, because I like to do pictures because some people do really well with visual images. Jonathan taught me that last year. Some people are better with pictures than with words. So these are just examples to give you that visual. Okay, so we have our 2 pointers that I created. So the data in the first one is 1, the data in the second one is 2, the data in the third one is 3, right? We got that from the last slide where we set the data. Everyone good with that? Okay, so now to make this a linked list, I have to update the pointer part of my node in order to link them all together. And you do that, so my 1 pointer subnext the next is equal to the address of this guy. So now this part of my struct is pointing to the next guy in the list. So now we actually have a linked list. We're linking them together. Okay? And then 2 pointer, I set it equal to the address of this entire node. So now this guy here is pointing to this entire struct. So now we have a linked list of 3 nodes. Notice that the pointer on the third one, I set it to null because there's no one else after this. This is the end of my list. That's how you know when you're at the end of the list, if the pointer is null. Make sense? Okay, so now we have a linked list of 3 nodes. And so this is interesting. So I can do next subdata is equal to 2, right? Yes.
on the previous page, you have selected all the nexus at the moment. We just skip square and stuff except the
Right, so I initialize them. All right. Okay. So I initialize my nodes. I set the data for each one of them, and then I each of my pointers is null because all I have is my nodes, and they're not linked together yet. Okay? You can. Oh yes, yes. I'm doing this step by step and breaking it down, just so that we are all testing. Is that okay? If it's too slow, I'm sorry. Okay. So the next step is we want our nodes to be linked. So we're explicitly linking them all together. But no, we don't have to do these 2 steps. And you'll see the code example does it. this is just to be very explicit about how nodes are going to look. Cool? Okay. So here, this is kind of interesting that we can actually reference data just through the pointers and the struct. So in reality, the first next, so data is 2. If you do next data, literally next data is 3. You go to the next one, and you get an error. Because there's nothing after that, right? Because this is an element. Make sense? All right. So, again, here in our struct, when we actually create our struct, I actually create the head of my linked list right there. So it's already created, and it exists global. You guys remember global versus local? Okay? So this is global because I declare it here outside of any of my functions. So that makes it global. Whereas here, these guys only exist in function of head. That makes them local. We go with that? So you'll see that throughout this application, we are referencing head because it's global. So we can do that. See? We only have one instance of it. And so that's important because you want to know where the beginning you live at all times. You want to make sure that you don't accidentally update that. So always keep up separate pointers when you're actually manipulating the linked list itself. So here, so this is global, right? We all agree? Agree with that? Yes.
What is happening on the malloc?
Which one?
Any of the like technical stuff that was malloc.
This one? So we are explicitly allocating space for that pointer. And then in front of it is an explicit typecast, which is kind of redundant. You don't really need that explicit typecast, but it's even though you don't intend it, I'm going back. You want to make sure this is exactly what type structure. Make sense? All right, so we want to actually be able to traverse our linked list. And you don't want to accidentally update that. I'm sorry, go ahead.
Is like next or previous somewhere in the code, like initializer, there's the code already know what next.
Okay, so next is part of the struct. So in our struct definition, we had an int called
Other
data.
than being in the struct though, like how does it know to go to next?
Okay. All right, so we create this struct right here. And we have 2 pieces. Our structs always have 2 pieces when we're doing nodes for linked lists. They have the data part, and then they have the pointer part. Okay? Good? So here's the data, and we just set up our data here. The name of our pointer in our struct is called next. We do that on purpose because it logically makes sense. You don't have to call it next. You call it whatever you want. But next makes sense logically because in a linked list, that means this is the next node. And then when we do doubly linked lists, when we add the previous, we use the word PRDV for previous because it logically makes sense. So we make it as logical as possible to not be confusing. Does that make sense?
Yeah.
Okay. So the next is the address of the next guy in our list. So that's how we get to this. We want to link them together. So you explicitly set it. So the pointer part of my node, I just called it one pointer, is the address of the second guy. So I have a memory address where this guy lives. And I'm telling this piece of my struct where it is. So I know how to get there.
Okay, so the only time you would use like next data is if you've already done a bunch.
You have to have your pointers, you have to have a linked list for that to work. If you don't have a linked list, if there's just the individual nodes and we haven't actually set the addressing for each one of our necks, it's gonna go, I have no idea what you're talking about. It'll end up being null. Good? Okay. Beer violation, yep. It should be, yes. Okay, so Jonathan brought up a good point. Again, I'm just oversimplifying the code. But if it is confusing you, then I will be very explicit. Better? Sure? All right. He's usually on. No, you're right. You're correct. Jonathan keeps me on. You all should be very grateful for him. Okay. So we go with this? All right, so here. Now, when you want to traverse your linked list, all right, we've gotten to the point where we've linked all of our nodes together and we have a linked list. Make sure you don't accidentally update that guy called head because he's the beginning. And if you lose track of that, you're completely hosed. You're just like, it's just, you're lost. Kind of being lost in the woods and you don't know where you're going in the dark, you know? So here, what you do is you create them. I just have 3 examples. You can call them whatever you want, okay? Lots of times we use temp because temp means temporary. You know, just using this temporarily to allow us to work through our array list. Sometimes people call it a helper. These are just different names that people have used that might make sense to you. Or just, for example, online, the linklist.c, it just has n in there, or n for node. Okay, it doesn't matter what you call it, as long as you know what you're using it for. And again, we talked about this on Wednesday. I'm a huge fan of always initializing my data. I want to make sure that there's no way at all that I accidentally have something in there. Or if I ran into a buffer overrun from something else that I did incorrectly. You know, let's say I created a character array of size 0, then I put 15 characters in it. I want to make sure that my data is good, so I definitely initialize all the variables. So, how do you actually do this traversing? So, I initialize what my helper, whatever that guy is, to the head. So now they're both pointing at the exact same location, right? You're like, okay, we're both right here. So how do we look at this in the code? So let's start down here in our main. So in my main, we have an int I, an int num, and a struct node called n. So this is kind of like my helper guy, my temporary dude, right? So here, definitely initialize the beginning of my linked list to null because I want to make sure that at the very start of my application, I definitely know where I'm starting. There's no question whatsoever what's going on. So here we're going to loop until we actually want to exit. So this while one just says while true, and it just keeps looping until we explicitly say, let's get out of here. And that explicit, let's get out of here, is the exit 0. You guys remember that from C? Okay. So here we're offering our users 5 options. And depending, and we're going to do a scanf to read their input, and a %d means decimal, base 10. And we're going to read that into the address of our I. And we're going to compare it to less than or equal to 0. Because we want to make sure that they don't put in an invalid number. And then here, we're going to do an evaluation on that. So some people told me they didn't even cover switches in C. How many people are in that situation? Whoa. Have you taken any of the languages?
Covered the project oriented.
Okay.
Same thing, right?
Yes, they are. Okay. So has someone not covered switches in C and not taken it in another class? Holy crap. I am very sorry. Okay. This is I'll go over it really quick. Again, this is one of those situations. Definitely go to this tutorial. Some of this stuff, you really should have already had it by now. And it's really unfortunate that you're not. But this will give you a voice track to it. I'll go over it really quick. But if you want in-depth reading, definitely go to one of these more reputable tutorials that will discuss, lay out the words for you. So basically what a switch does for you is this. Are you comfortable if, else, if, else, if, else? Yes? Same concept, different construct. Okay? So the difference between if, else, if, spelled correctly. And 2 words, not one. Else, if, else. Okay? So the switch and the if, else, if, else, if, else is the exact same concept, right? But the difference between the if and the else if and the switch is the switch will evaluate every condition regardless if it found an answer. So, and I'll show you how you get out of that once you do find your answer. All right? The if, else, if construct, once it finds its answer, it fails out of the logic. That makes sense? So the switch will give you potentially multiple opportunities to come back as yes or true, whereas if, else, if, you only get one back. Okay? So in our switch, so this is the construct. So this would be the equivalent of your if, okay? In each one of these cases, this is called case label, and the case is what you want to evaluate. Yes, sir. You can evaluate what? Comparison. I'm not the TCS, I don't remember that, but I will look it up. Okay, so here, if my value of my I is 1, then I'm going to execute these lines of code. If the value of my I is 2, I'm going to evaluate these lines. I'm going to execute these lines of code. If it's 3, I execute these lines of code. If it's 4, so each one of these cases, these case labels are just like an if, else if. Does that make sense? Okay? So for your else, for the default, if you go find your answer, it literally is default. This is if I got through all of my evaluations and none of them matched, and so I need to do something. The default is not required. Just like when you do an if, else if, the else is actually not required. Because in some cases you don't want an else, you don't want a default case. This is not required. This is just good programming practice to catch it. Okay, it's another one of those user-friendly things.
In this particular instance, is there any advantage of using switch and CF output outside of readability?
So the else is the same thing.
So if you don't break out one of the other options,
Yeah.
the other one, you get one of those statements,
Because the thing about the switch is it keeps evaluating. Even though it finds its answer, it still evaluates the rest of the options. Where in an if and else if, it's definitely not going to do that. It's going to fail.
Yeah, but you're just breaking out of it.
But yes, okay, so my next point is, I'm sorry, go ahead.
So it's like the switch statement is more like a menu more than anything compared to the if else, I guess.
You can look at it like that. If it makes sense to you that way, then yeah, it just gives you multiple options for evaluation versus only one possible answer.
Okay.
Now, to force that behavior you do a break. Let me show you what happens when you don't do your break. So here, I'm going to comment that guy out. And you'll see why you want your break statement. So what happens is, if you don't put a break statement, if you don't say, I executed all my lines of code, let's please get out of the switch statement because I'm done. If you don't do that, once it comes back and evaluates true, everything after it is considered true. Now that cannot happen in if else by any means. Okay, so I have no break statements. So if I enter 1, it has just evaluated, it has just did all the other stuff too. You see that? It didn't do just the stuff in case 1. It did all the stuff from case 2, case 3, case 4, and case 5. That's not the ideal situation. You definitely want to make sure that it stops when it finds its answer. So you want to definitely have those break statements in there. Okay. Now, depending on the language and what version we're on of the language, whether or not you have to put this code in between curly braces or not. Typically, the general rule of thumb is if you have more than one executable line of code, you usually use curly braces to represent it, right? Switch statements are a little bit different. You kind of understand that. Anything in between each case label belongs to that case. I do it anyway because it makes me really uncomfortable to not know for sure that my stuff is representative. But it's not mandatory. Okay? Now, some languages actually do require it. I would have to look that up and tell you specifically. But just know that in a switch or in a case, you don't have to have those brackets, the curly braces, to bracket it. Do you feel comfortable about switches? It's just like an in elseif. Okay, just a different way to do it. And it functions just slightly differently, but you can pretty much get the same behavior from an if elseif. And then it kind of ends up being more of a preference. All right, so I'm evaluating my I, whatever the user said, with their option list. If it's 1, we're going to go and we're going to ask them to enter their number, and then we're going to call this function insert. If it's a 2, let's see what our 2s are. So 1 says I want to insert data into my linked list. 2 says I want to display. Get out of there. Got it. 2 says I want to display everything into my linked list. 3, stop that. Says give me the size of my linked list. 4 says I want to delete something from my linked list, and 5 says, hey, we're done. Let's get out of here. I'm done playing. All right. So here we have our insert, and then on 2, we're going to call the function display. So here, we're checking to see if our head is equal to null. If it's equal to null, that means we have nothing in our linked list yet. It's just completely empty. So remember, we initialized it at the beginning, okay? And then otherwise, if it is, we're going to say, hey, this is how many elements are in there. These are the elements in our list. We're going to call it function display. And then down here, in 3 was how many elements are in our linked list, and we have this function called count. So we'll call that function, and that function obviously is going to return the index and give it the size. 4 is going to, if the delete, we want to delete something. So again, we're going to make sure we have anything in our linked list to delete. And if not, we're going to go up to the empty, so we'll do something to delete. Otherwise, we're going to ask them what number in our linked list do we want to delete, and we're going to call this function delete. Now, you notice this isn't an if, so what's going to happen is I return, our delete is going to return a value of whether or not they actually found that number, so that we know. So let's say we have numbers 1, 2, 3, and we asked it to delete 4. Well, you're asking it to delete a number that's not there, so you just want to provide back to the user information that it's not there yet, okay? Otherwise, it's going to say, yep, I deleted it. And then 5 is just calling you exit. So are we good with the name? And see here I have a default. So in case the user enters an option that's not on the list, we said option 1 to 5, but they enter 6. We want to tell the user that that's not an option, try again. Make sense? Are we comfortable with the name? Okay. Game. I talked too slow. Slower after. Okay. For those of you that get this and feel like, holy crap, we should go any slower, I just want to make sure that we all understand what's going on. Okay. So there's a lot going on in this application, and I want to make sure that we are actually discussing every piece of it, because the homework assignment I will publish for you this afternoon is going to be 4 linked lists, so it's very important that you understand this. Okay, so our entry point, I'm sorry.
If you are just switching to 0, will it be the first one?
No, that's very important. Because the only cases that are labeled are 1, 2, 3, 4, and 5. 0 is not one of them, so it's going to hit the default and go back to count. Yes, sir.
So if you want to see code block,
Code blocks is going to definitely be a lot easier. Because with NetBeans is not inherently an IDE for C++, so there's a lot of plugins that you have to apply, and we would end up spending the whole week just discussing how to get NetBeans set up. So code blocks is like, bam, you're right. Super easy. So, but I mean, if you have Visual Studio, it's pretty good. You guys get that for free. So, but whatever you want,